Regenerative and eddy current braking. In this presentation, we're going to take a brief look at these two specialty forms of braking technology. Regenerative braking collects the energy that would have been wasted during the braking process and converts it into electrical energy. It then sends it back to the original source of supply. In this electric train, the DC machines that would be used for the motors, that are the traction motors, turn into generators when we are requiring braking. And at this point, they generate electricity due to the forward motion of the train. The energy is then sent back up to the electrical current supply. Regenerative braking systems can be designed with wound rotor motors, DC motors, and specialty electronic motor controller systems. On a standard wound rotor motor with DC injection braking, one would expect a small amount of energy to be consumed or power to be wasted, as there is some form of current that would be induced into the rotor depending on the speed and the value of torque that we required. If we were to then connect this into a dynamic braking situation, there would still be voltage being induced into the rotor and therefore current flowing. And that current would then be flowing through the resistors, and the power being consumed through the form of heat would be considered waste. Instead, a wound rotor motor could be set up with a form of specialty electronic controller that not only controls the rotor current during startup and determines the torque value, but also is able to use the current that flows from the rotor during the dynamic braking process, convert it into AC and back to the supply. The other form that we have is through variable frequency drives that are specially designed to take the energy that a driven machine will cause to be developed in an AC motor. Depending on how an AC motor is operated with a variable frequency drive, we can generate energy from it, even a basic skim motor. However, this is a topic of further explanation that we're not going into in this particular presentation. Sufficient to say, the AC motor will generate some amount of energy, which can then be transferred back through the variable frequency drive to the three-phase AC supply. When a ferrous metal is rotated between two magnets, eddy currents are established. The eddy currents create an opposing magnetic force against the original magnetic field. Consider Lenz's law. This opposing magnetic field is what slows the rotor with eddy current braking. Interesting to note, with any eddy current braking, zero physical movement means zero eddy currents being induced, and finally, zero braking force. What we need for a system like this is an electromagnetic coil and some form of a ferrous metal in the form of a disc brake. When we look at the two, we see on the left a friction disc brake where the pads are up against and making physical contact with the disc brake, whereas on the eddy current disc brake, although it may look similar, there is zero friction. And so because of this, it is considered to be advantageous because the amount of maintenance and replacement of parts is almost zero. Now, this doesn't mean that no heat will be developed because eddy currents develop heat inside that rotating disc that we see on the axle of a train bogie. There are other types of eddy current brakes, this one showing a linear eddy current brake, where the electromagnetic coil is then lowered down over the rail that the bogie is running on and creates the eddy currents in the rail itself. This eddy current then slows the entire train by having an opposing effect with the linear electromagnetic braking system. We also see different types of eddy current systems used in the recreational fall arrest systems, like at indoor climbing gyms, as well as job site fall arrest, where we have to wear a uh, full fall arrest. Boy, the name evades me here. What the heck am I looking for? Harness. There we go. Good gravy. Eddy current brake systems are used in specialty applications for transportation and industrial installations. They're also used in basic fall arrests used by workers. They create braking force when a magnetic field is applied across a rotating disc, and the higher current, if we were to apply higher current, would mean a larger magnetic force and a stronger braking force. Finally, if there's no rotation of the disc or physical movement, we get zero braking force out of this system.